Hello, my name's Derek Marshall from Renishaw's Machine Tool Division. As you know, we are launching our Sprint on-machine scanning system at the EMO trade show this year, so I wanted to take this opportunity to go through some of the different components of the system and explain some of the differences between the Sprint system and a traditional touch trigger measurement system. So first of all, this is the Sprint OSP60 scanning probe. Looks like one of our normal probes, so the diameter of this unit is about 60 millimeters. The back end, for those people familiar with probes, it's compatible with our OMP60 range of shanks to fit in most machine tools. You can see that it's got a battery compartment, so the probe unit is tool changeable. It communicates by infrared using these infrared LEDs on the outside of the probe, and it also has a stylus on it. And then there are some things that are a little bit different. When you move the stylus, obviously with a normal probe, it's just like a switch. So with a normal probe, you kind of can feel the mechanism. With the Sprint stylus, it's analog. So inside this probe, it's measuring 1,000 points per second in true 3 dimensions. So it can measure whether I push the stylus this way, or in and out. And as a result, the stylus has got some play to it. So it does feel a little bit different to a normal touch trigger probe. You'll also notice on here that the stylus has got a number engraved on it. That's one of the differences. There's also a much thinner stem on the stylus, and that's because when you're scanning, the probe is constantly deflected, and therefore you need more clearance between the ruby ball and the stem to allow you to make a bigger scanning measurement range. The number is engraved on here for increased accuracy, so you can use this number when you set up the Sprint system to really give yourself the best accuracy during scanning. So, as I said, the OSP60 probe is broadcasting. It's measuring 1,000 data points per second in true 3D. It's got a unique capacitive 3-dimensional transducer inside it. The probe has been through all our normal test programs. It's absolutely as robust as any of the other Renishaw products which you trust. So we've got infrared signal being broadcast out of the probe, and it communicates to this device. So this is the OMMS. So as with a normal Renishaw system, this is mounted on the wall of the machine, and it's communicating via infrared with the OSP60. It's actually bidirectional communication because, as we'll discover, timing is very important when you're trying to synchronize measurement data with the Sprint system. So the OMMS, you can have up to 2 of these in your machine. So if you've got a large machine, or if it's, for example, a tilting head type, then you can use 2 of these to ensure that you've got line of sight. It communicates with the probe and controls functions like the switch on and switch off, and it also gathers the measurement data. This is a unique interface for the Sprint system. It obviously comes with a cable. You can see here it's all curled up out of the box, and that cable connects into this device, which is the OSIS, and typically this would go in the rear cabinet, the electrical cabinet of the machine tool. There is obviously plugs on here for, sockets on here for 2 of the OMMSs. This device is like the heartbeat that keeps the Sprint system running, because as well as collecting timestamp data from the OSP60, this device also synchronizes the data coming from the machine tool. So it has a dedicated connection into the CNC machine controller, and every time we collect a data point from the OSP60, we also collect in parallel a data point from the machine tool controller. This device deals with the clock signals for that, and it also has an Ethernet connection which allows it to communicate with the software component of the system. So connected into this, there is a piece of software called the Productivity Plus CNC plugin, and what the CNC plugin does is it takes the 2 streams of data. One of them is the 3-dimensional probe deflection data from the Sprint OSP60, and the other one is the stream of position data coming from the encoders or coming from the CNC machine tool controller. In the CNC plugin software, we can combine those 2 streams of data, and using various calibration techniques or various compensation techniques which are calculated during the initial setup of the probe, we're able to combine those 2 streams of data, and as a result, we can get a very accurate reading for the position of the stylus tip. So there you have it, an introduction to the basic components of the Sprint system. Thank you for watching. If you want to understand more, please do make contact with your Renishaw representative. Thank you.